In this video, I am going to show you how to find the inverse of a logarithmic function. But first, I need to make sure you understand two more basic concepts that we're going to need. The first one is just how to find the inverse in general. So before we get into logarithmic functions, imagine that I had the function, let's say, f of x is equal to 2x plus 3, simple linear function. Now this would be the same thing as y equals 2x plus 3. So to find the inverse function, you do two things. You switch x and y, and then you solve for y. I'm just going to repeat that. Switch x and y, solve for y. So first of all, I switch x and y. So the x goes here, the y goes there, and then I'm solving for y. So if I would subtract the 3, so now I have x minus 3 is equal to 2y, and then I would divide by 2. Okay, so now I have x minus 3 over 2 is equal to y. So there I have solved for y. Now I can put this back in function notation with the f of x, but I need to put this little apostrophe in there. Okay, and I'm going to rewrite it from left to right. So this would be the inverse of function f, and the little apostrophe shows that it's the inverse. So that's the first concept I had to remind you of. How do you find the inverse in general? Switch x and y, solve for y. Now here's the second concept that we're going to need to deal with logarithms. You need to memorize how to switch back and forth between exponent form and log form. So for example, I'm just going to use a, b, and c. If I have a equals b to the c power, this is called exponent form. We have a base and power. Now, in logarithm form, obviously there will be a logarithm in it. Now, focus on the base, the b, all right? The base is the key to everything. So in logarithm form, you write your log, and then that base goes here. See how it's hanging low? It is a subscript. So log base b. Now the a and the c are basically going to switch places. So the c is going to come over here, and the a is going to come over here. So exponent form, log form. All right, you need to be able to go in the other direction too. Let's see, here's something in log form. Say if I have p is equal to log base q of n. All right, I should be able to rewrite this in exponent form. Now again, focus on the base. The q is the base. So, and I'm going to keep this q on the same side, and I'm going to write it as a base. So in exponent form, you have a base, and it gets a power. Now what power? Now the p and the n switch sides. So the n is going to wind up over here, and the p is going to wind up over here, but now it's going to be the exponent. So this would be the exponent form. All right, now we're ready to find the inverse of logarithmic expressions. So we are going to find the inverse of this function, this exponential equation. And anytime you're finding the inverse, it involves two steps. You need to switch x and y, and then solve for y. So first I switch x and y. So that's going to make this x equals 5 to the y power minus 5. Now I need to solve for y. I need to get y by itself. So one thing I can do to get closer to that is add 5 to both sides. So now I have x plus 5 is equal to 5 to the y power. So now I need to get this y by itself. When you have an exponent, the way to get that exponent by itself is to rewrite this in logarithmic form. So that's what we will do. Now, when you switch forms from between exponent and logarithmic form, focus on the base, which in this case is 5. In log form, that base goes right here as a subscript, log base 5. Put it low. Now, the y and the x plus 5 are going to switch sides of the equation. So the y is going to come over here, and the x plus 5 is going to come over here. So this is the same equation in logarithmic form. But in log form, the y is by itself. So this should be the answer. So let's find it. See, log base 5 of x plus 5. It looks like D is our answer.